Computer systems use 2's complement notation to store negative and positive integers. The most significant bit of a number is used to define the sign of the number. For instance, this number here, 1 0 0 0 0 0 0 0, is an 8-bit binary number, base 2, and the most significant bit is this bit here, the most leftmost bit in the number. This is called the most significant bit. And it's called the most significant bit because it has the highest value, it's the most value. If it contains a 1, it means it's a negative number. So if the digit is a 1, it's negative. And if it's 0, it is positive. Okay, so this is a negative number we're looking at here. It's actually negative 128. Now how it works in 2's complement, this most significant bit, it doesn't matter how many bits are used, it might just be 4 bits, but whatever one is the most leftmost, it's got the highest value, it's always, its value is actually the negative. So if it contains a 1, it means it's being used, and it's a negative 128 that's being used. All these other numbers are added to it. Now that might sound a bit crazy, but when we're checking our calculations, we can use this method to check them. So when you are creating a positive number, so for instance, say it's the number 33, then we're going to need a 32 and a 1, and the others will be filled in, and the most significant bit will be 0. So as normal, we're not including 128, we're not including 64, but we're adding 32 and 1 together to give us 33. This one up here was minus 128. So the most significant bit in this case, because it contains a 0, it's a positive number. Now let's have a look at the number minus 45. So let's say we want to find the number minus 45. So what we need to do here is a 3-step process. The first step is to find the positive, so positive 45. So we need a 32, we need an 8, we need a 4, and we need a 1. We don't need a 2, we don't need a 16, we don't need a 64, and we don't need, right, so we've got 32 and 8 is 40, and 4 is 44, and 1 is 45, so that's the positive. It's got 0 here. Then the next step is to invert this number, so I'm going to change my pen here, so that invert it means flip it. So, and then the next step is to add 1 to that, so put a 1 here. Okay, and then we add them up. So 1 and 0 is 1, 1 and 0 is 1, 0, 0, 1, 0, 1, 1. So this is the equivalent of minus 45. We've got the most significant bit is being used, And what I was saying earlier on, this most significant bit, because we're using 8 bits here, it has the value of minus 128. So let's see if we can work this out then. So that's minus 128 plus 64 plus 16 plus 2 plus 1. Now let's see if we're right. So 64 and 16, that's 80, 82, 83. So we've got minus 100 and how do we get minus 128 from 83? So we could say 83 and 45 is 5 and 3 is 8 and 128. There you go, that's how we find it. So if you start on your calculator with minus 120 and then add 64 and add 16 and add 2 and add 1, you will be left with minus 45. So this is how you check your answer. Right, so let's recap on the steps to create a negative number. So there's 3 steps. Step 1, find the positive value of the integer. Step 2, invert it. And step 3 is to add 1. Okay, now let's think about the range of numbers then that can be represented in 2's complement. So the range of numbers. So let's start with a nibble. So we've got 2 to the power, oops, what's that? 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. So that is 8, 4, 2, and 1. So we've got 4 bits here. The most significant bit is if it's 2's complement, then this is a minus 8. If it's got a 1 at it, it means it's been used. So 1, 0, 0, 0 gives you the lowest negative number, which is minus 8. So we can say minus 8. And what's the largest positive number we can get? So we know that this is minus 8, so it's nothing, no help to us whatsoever, which is why it's got a 0 in it for a positive number. And if we use all of those, then we're 4 plus 2 plus 1, so it's 7. From minus 8 to 7 is the range for 4 bits. So that's the 4-bit range in 2's complement. What about what if the question was in 8 bits, the range of positive and negative numbers that can be represented in 8 bits using 2's complement. This is a common question in your exam. So we've got 8 bits. So we know that 2 to the power 7 is 128, and in 2's complement that would be a minus 128, and if it's got a 1 at it, it means it's being used. So minus 128, 2, and the positive numbers would be 127. what would that look like in binary? So that would be 1 0 0 0 0 0 0 0 2 0 1 1 1 1 1 1 1.